today we will study about Penk's model of the cycle of erosion. So this is also known as morphological system model of landscape, which was given in 1924 by Penck. And this model was given after Davis. So you can say that this model is based upon the criticism of Davis, or this model is based after studying Davis cycle of erosion. This model has been based on. So he studied, this is Walter Penck, so he studied the Davisian model first, but he could not adopt it as a whole. He was a German geographer, so he could not adopt it as a whole. He agreed on certain points of Davis' thoughts, but he disagreed on certain points. So what are the points? He disagreed on the trio component. So the process, particularly the process and the stage components of Davis. So he disagreed on that point. Particularly, he was against the stage concept of Davis, that is the youth and the maturity and the sequential landform, the sequential stages that he has said about. He said the stage cannot be sequential. He rejected the stage is not sequential. Because according to Davis, if you remember, he said that it is an orderly sequence. It is a cycle from youth, maturity, old, again rejuvenation, again youth, maturity, old. But he said that this need not be the case. Stage may not be sequential because there may be interruptions in that sequence because of rejuvenation. So maybe a cycle can directly jump from youth to old or from old to maturity. So it need not be sequential, and there are other certain basic differences between these two concepts. So he, in the place of stage, he did not use the word stage, but he used this German word, Entwicklung. So this German word means development. Entwicklung means development. He used another concept, that is a Treppen concept. Treppen is another German word which means steps. Steps. So development and steps. So this is the picture of the Black Forest of Germany. And you can see over here steps like of landscape. Here step, then again another step. So there you can see a step kind of land feature. So this step concept of Treppen concept, it was used by Penck to explain the Piedmont benchlands that surrounds the Black Forest in Germany. And these geomorphic features are numerous broad steps, as you can see over here, which resulted as result of continuous uplift. So because there was an uplift of a dome mountain, there would be various steps. So as this dome mountain, it witnessed various stages of uplift, continuous uplift, thereby creating various terrace landform, which he termed as the Treppen concept. Now, what is the basic principle of Penck's Entwicklung concept? What are the basic principles? So as you see, the first thing is, as per Walter Penck, the endogenic forces, they interferes with the cycle of erosion through rejuvenation. So there are various endogenic forces. I have already told you about endogenic forces and the various exogenetic forces in my previous lectures. So endogenetic forces, they will interfere in the cycle of erosion. So through which force? Maybe through the force of rejuvenation. So through rejuvenation, through upliftment of the landmass, that cycle will be interrupted. So maybe a cycle is in its mature stage, but if that landmass is uplifted, then again it may go back to its previous stage. So endogenetic forces will interfere in the cycle of erosion through rejuvenation. Hence, if this is interfering in the cycle of erosion, if rejuvenation is interrupting the cycle of erosion, so we can say that erosion or this cycle, the cycle concept which Davis had given, so that we can say that it is not a time dependent factor. Like if you remember the stage concept, it was T. The concept of stage was denoted by T or time. So according to Davis, stage has been equivalent to time. So, but over here, if endogenetic forces is interfering in the this cycle of erosion, then we cannot say that it is a time dependent. So, erosion cycle is a never-ending process. As soon as there will be a rejuvenation, again the erosion will start. So, we cannot say that after old age it's stopping. It is not like that. According to Penck, it is a never-ending process. Again, Davis had said that erosion remains suspended during uplift. That is what Davis had said. His basic principle was erosion remains suspended during uplift. But Penck has said that both of them are coexistent. That is, both upliftment and degradation, it is a continuous process. They are coexistent. So according to him, according to Penck, it was against the Davis idea of trio. He was against that idea. So contrary to the idea of Davis that landscape is the result of trio operating in a stage manner, he said that these two, erosion and uplift, these two are coexistent and erosion does not remain suspended till the uplift is completed. Again, contrary to the Davisian idea, concept of uplift, which he said that uplift is only once. According to him, no, uplift cannot be only once. According to he mentions that there are different phases of uplift. So these phases of uplift and degradation of landform is a result of what is, and we will see what are the various phases of uplift in the coming slides. So according to him, there are various phases of uplift, and these phases of uplift are due to what these phases has been created. These phases are occurring because of the various interaction between the degradation on one hand and uplift on the other hand. So degradation on one hand and uplift on the another hand will result to various phases. So it is written changing rates of uplift. So according to Penck, uplift is not same throughout. So the uplift will be different in different phases. So he said, and as I told you, it will be according to the two factors, that is uplift and degradation, which is a continuous factor. Also, he says that landform is the ratio, it reflects the ratio. Landform, the end result, the landform is a ratio of what? Is a result of what? It is a result of the intensity, how intense is the endogenetic processes works, and with that, what is the magnitude by which the various materials are dislodged or displaced. Displaced by what? The exogenetic forces. So over here, the exogenetic forces means erosion and endogenetic forces means upliftment. So Penck's, there are two things over here. See this one. There are two things. One is erosion and one is upliftment. So these are one of the, you can say, one of the basis of Penck's principle, erosion and upliftment. So these two differs. According to these two differs the what would be the rate. According these two results, what would be the landform, which is the result of what? Erosion and upliftment. So erosion is what? Exogenetic forces. Erosion is through exogenetic forces, and upliftment is through the endogenetic forces. So landform is a result of these two things, exogenetic forces and endogenetic forces. Now, rejuvenation in Penck's idea, in Penck's principle, has taken a central point. It is an important step, rejuvenation. So according to him, through rejuvenation, the cycle can again return back from the old stages to young stages. And this rejuvenation, it occurs through two processes. What are the processes? Either the base level is lowered or the landforms are uplifted. And Peng's idea, Peng's model, it basically revolves around erosion, just like I told you previously. Erosion and rejuvenation. So one of the concept of rejuvenation I told you, and the second concept of erosion, that is his another pillar. So according to this erosion, so erosion can be this erosion because of erosion. So erosion can lead to various types of landforms. So his concept was based upon erosion, transportation, and deposition of those eroded materials. So that would lead to erosional landforms, transportational, and deposition landforms. And this whole system of Peng's model is that landform of a given region, this is related to the tectonic activity of that region. Why tectonic? Because otherwise there won't be any rejuvenation. So he used the word tectonic activity of that region. Now, as I told you, Entwicklung, which means development. So this was the term which was used by Peng in the place of stage, the stage concept that was used by Davis. Now he used basically three Entwicklungs, these three Entwicklungs. But what is Primerrumpf and Endrumpf? So Primerrumpf and Endrumpf, these represents the initial and the end product of this cycle. So Primerrumpf is the initial and Endrumpf is the end product of this cycle. So there are three Entwicklungs in this erosion cycle. In the place of youth, then maturity, and then old. In place of those youth, maturity, and old, he used Aufstehende, Gleichformigkeit, which is subdivided into three subphases, and Abstehende. So over here in Aufstehende, there is accelerated rate of development of landform or the height of the landform, uniform rate of development of landform or height of landform, and decelerating rate of development, or here the landform development slows down or ends completely. Now let us see each of these features. So Primerrumpf is the term which was used by Peng to denote the primary land. So this represents the landscape before upliftment, before it has been uplifted. So before upliftment, that is Primerrumpf. And you can also think that this is in fact this Primerrumpf is in fact the initial surface which Davis used as peneplain or primary peneplain. You can so Primerrumpf is equivalent to primary peneplain. So this is the initial surface before upliftment. So this Primerrumpf or primary peneplain or primary peneplain, whatever, this is the prior stage of landform development. And in this stage, there is no landform development. There is nothing, no landform development. And this, during this stage, the landscape, it starts to rise, it starts to develop, but then there is no mountain in this stage. And the UC and the LC, I had already told you about UC and the LC, that is the upper curve and the lower curve, is the same over here. But the rate of upliftment here varies. Now let us see the first stage, that is the Aufstehende. So before this is the Primerrumpf, so there is no development, no landscape development. Landscape development starts from here, from Aufstehende. And this is the upper curve, and this is the lower curve. And over here, Aufstehende Entwicklung, what you are seeing, the rate of upliftment is greater than the rate of erosion. This is in his first, according to Peng, in the first stage, in the first Entwicklung, the rate of upliftment, the landform will be uplifted, the rate at which the landform is uplifted is much more than the rate at which the landform will be eroded. So that is what is That is one of the most important principle of upstage ende. Now let us see what are the various principles of upstage ende. Now this is the phase of waxing or accelerated rate of landform development. So initially you see how the rate of landform is developing. You can see this is the highest point. So the highest point is where in the offstage and Entwicklung. After that, the landform is slowly, either it is uniform or then it is moving down. But the highest point has been noted in this offstage end. And the rate of upliftment also see is maximum. Over here it is only uplifting, it is only increasing. Though it is over here it is uniform and it is going down, but here it is only going up. So this is the phase where the rate of upliftment of the land is the maximum. And in the initial stage over here, see the gap here and the gap here. So in the initial stage, the upliftment of land is slow, but after some time, the rate increases. The rate of upliftment, first it is quite slow, but then the rate of upliftment increases. Now, due to this increased uplift, channel gradient also increases. Channel gradient of the rivers, they also increases. Now, when channel gradient increases, then the flow velocity will also increase. With more and more rivers joining in, the volume will also increase. So when the volume increases, the flow velocity increases, then the kinetic energy of the river. So kinetic energy means the erodibility, how more it can erode. So the kinetic energy of the river also increases. Now, when the kinetic energy of the river has increased, the flow velocity has increased, the channel gradient increases. So this will lead to what? This will lead to the river will start degrading their valley or cutting the valleys. The river will start eroding the valleys. Because the kinetic energy is more, so what will happen? There will be V-shaped or down cutting will be much more. The river will cut in a V-shaped formation. But over here, so there will be narrow V-shaped valley and deep and narrow V-shaped valley. But the rate of upliftment over here is more, what is written, the rate of upliftment is more than the valley deepening. Since rate of upliftment is more and than erosion, and whatever valley deepening, it will be narrow V-shaped valley. So this results in narrow V-shaped valley. Because the rate of upliftment is more than that of erosion, so this results into narrow V-shaped valley. Now, as the rate of upliftment is more than the valley deepening, so this will result in the maximum altitude and the maximum relief. Because erosion is lesser or erosion is lower than uplift, so it is very much obvious. See over here, the maximum relief has been attained in this stage. Over here, if this is the point of maximum relief, then no other part of this cycle attains that relief. So maximum relief has been attained here. Why? Because the rate of uplift is more in this particular stage. In no other stage, the rate of uplift is more than erosion. But only over here, since the rate of uplift is more than that of erosion, so because of more uplift, the highest relief, the maximum relief is obtained in this phase itself. Now, this will result into, because of all this erosion, this will result into steep and convex valley slopes. So, and with the passage of time, the whole area will be surrounded by a series of benches. The Primorem will be surrounded by a series of bench-like formation. So, which is called the Piedmont Trapeze. So, because of various phases of uplift, more uplift, lower uplift, lesser uplift, so various phases of uplift, a bench kind of formation will occur, and this bench type of formation has been termed as the Piedmont Trapeze. Now let's come to the next phase or next Entwicklung, which is called the Gleich-Formige Entwicklung. So what is the Gleich-Formige Entwicklung? So according to this Gleich-Formage-Entwicklung, it means uniform development of landscape. So this phase is divided into 3 more phases. So this one is the Gleich-Formage-Entwicklung. This is the Gleich-Formage-Entwicklung. So this, as you can see, A, B, and C. So this has been divided into 3 phases. So this, what are the 3 phases? So let's come to the first phase, phase 1 or phase A. So this is characterized by what? Uplift is still greater than erosion. So this is characterized by accelerated rate of uplift. Now, because it is accelerated rate of uplift, so absolute height is also increasing. Absolute height is a total height. So over here, you see over here, if this is still A, so over here, it is still increasing. The height is still increasing over here. After that, the height may be something else, but till here, till here, the height is still going on increasing. So the absolute height is also still increasing over here, because the rate of the erosion is still lower. But here in this phase, the relative height is increasing in lower rate. Because over here the maximum altitude is attained, but relative height remains constant. Now, why this remains constant? Relative, I have already told you what is relative height. Because relative height is the highest height minus the lowest height, the highest height minus the lowest height. Now, relative height, it is not increasing. At first, it is increasing, but then it remains constant. It remains constant. Why? Because though the valley deepening is there, but at the same time, the summit is also getting lowered. The summit is also getting lowered. So because the summit is also getting lowered, so that is why, and plus there is valley deepening. So had there been no erosion in these parts, only erosion over here, down cutting, then the relative relief would have increased, because relative relief is highest minus lowest, highest height minus lowest height. But if there is erosion over here, then supposing till here the erosion was maybe the height of this mountain is 10 meters and this valley floor is maybe 2 meters. So that means relative relief is 10 minus 2 is 8 meters is relative height. But supposing this valley floor is deepening, but then this portion is also, there is also decrease in this portion. So the relative height won't be the same, won't be 8 meters. So although over here it is increasing, but at the same time, there is erosion in these parts also. So that is why, because of erosion plus upliftment in these parts, so relative relief remains same. And as you can see over here, the valley sides are straight slopes. So because of this, because the rate of valley deepening and the lowering of summit is almost same due to weathering, so this phase is called the phase of uniform development. Now let's come to the second phase, phase B. Over here, uplift and erosion is almost the same. So absolute relief in this phase, it neither increases nor decreases. So over here, there is uniform. As you can see over here, the absolute relief, the total relief, it neither increases nor decreases, it remains the same. Because uplift has ceased. Uplift and erosion is the same. So there is no increase, no decrease. Whatever increase is there is taken away by the decrease, that is erosion. So absolute height remains the same. Though rate of uplift still continues, but as I said, the lowering of divide also is there. The divides are also lowered. So because the lowering of divide, because of lowering of divide, though the rate of upliftment continues, but with the rate of upliftment, what it happens? See the divide of summits. The summits are also divided. Because the summits are also divided, and at the same time, rivers are also eroded, the valleys are also deepened, so the relative relief remains same. So there is uplift at the same time, divide of relief. The summits are also eroded, uplifted, eroded, valley deepened. So because of all these things, the relative relief remains constant. Here also slope of the valley is straight because you see parallelly it is retreating. It is retreating parallelly. So it is straight slopes. Thus we say here also uniform development of landform. In the phase 3, uplift slowly stops. That is why this thing, so this UC, so the UC falls because uplift stops, so UC is falling. So here we see absence of uplift, and this absolute relief, as you are seeing over here, absolute relief is starting to decrease because there is absence of uplift, so and there is erosion of these summits, so absolute relief is decreasing as you are seeing over here. But relative relief, it remains constant because although here we find erosion, at the same time here also we find erosion. So that is why relative relief remains the same. There is no increase, no decrease. Relative relief remains same because summit is also eroded at the same time at equal rate. Here it was also valley deepening is also there. So that is why the relative reliefs remains same. That is why this is also characterized by uniform development of landscape. So supposing the landscape over here, the height is maybe 8 meters, and here, supposing here it is height is 10 meters, and here the height is maybe 2 meters, so that means 8 meters, but over here the height maybe has fallen to 8 meters, but again this one has also come down to 0 meters because valley deepening is also there. So 8 minus 0, it is 8 meters. So relative relief remains constant. So we say this is uniform development. Now let us come to the next stage, that is the abstagende. So in abstagende, this means it is marked by progressive decline of landform. So this means abstagende means waning development of landform or decreased or progressively decline of landform. So over here, it is characterized by what? Progressively decline of landform. This is the abstagende part. So you can see how it is declining. Absolute relief also decreases. And this part is dominated, you see over here, rather than vertical, you see lateral erosion of river. Because why lateral? Because over here the kinetic energy was more, the gradient was more, but over here the kinetic energy and gradient has decreased. So instead of lateral, we find over here, instead of vertical, we find lateral more over here. And relative relief also decreases. Why? Because the summit is decreasing. Because of the summit decrease and almost no vertical deepening, so relative relief obviously will decrease. This phase, in this over here in this phase, parallel retreat, as you can see, parallel retreat of the slope is continuing. And in this phase, the valley side slope, it consists of two segments. So what are the two segments? So now the valley side slopes has been divided into two segments. So the uppermost part of the segment, the uppermost part, so this part, it has got steep sides. See the steep sides. So this is called a gravity slope because under the force of gravity, things can come down. So gravity slope, or it has been said in German word Boschung. And then we find this part, the lower segment of the valley, wash slope, where the various, it is composed of the or the Halden hang. So this is composed, what remains over here. So whatever eroded materials are deposited in these areas. So the talus materials of lower inclination are deposited over here. So this occurs due to the rapid parallel retreat of this gravity slope. This gravity slope is retreated back. So because if it is retreated back from here to here to here, because of parallel retreat. So what happened? This Bosch-Schwingen occurs. So ultimately, this it will go on retreating, go on eliminating, and ultimately it will go to the advanced stage of this phase, which is Inselberg formation. So the gravity slope will also be reduced, and then these gravity slopes will be consumed. These gravity slopes will be consumed, and then what will remain? See these conical hills, when the height has been, this height has been reduced to this and then this. So what will remain? Broad slopes, concave slopes with a few with a few conical hills like this, which are Inselbergs. So these conical hills will have steep sides, and ultimately this even this Inselbergs will be eroded, and ultimately there will be what the end of this phase is, this extensive almost flat surface, which is the Endrumpf. So ultimately there will be this kind of flat surface, which is an Endrumpf. There might be these Inselbergs, but then these Inselbergs will also be consumed eventually. So in this stage, in this Endrumpf stage, landform development stops completely and PD plane is developed. So PD plane, you can say that this is almost like the PD plane of Davis. So this is called PD plane. PD plane is developed, though PD plane concept is the concept of king. And this uppermost part is erosional. If you can see here, see the uppermost part is erosional and the downsides are depositional. So this Endrumpf is this is called the Endrumpf, which is similar to Davis peneplain. Now you must know what is the difference between Inselberg and Monadnock. In most of the books or in various online materials, these two has been said to be the same. But Inselberg and Monadnocks, they are not the same. So Inselberg, it is, you can say that this is a result of PD planes or wash slope. So PD planes is again the concept of W.C. King, and wash slope concept of Penck. So this is a result of Inselberg, is a result of that. But one of the most important things that it is of the same rock material. But Monadnock is not of the same rock material. It is of a more resistant rock than the surrounding rock. So because it is of the same rock material, so ultimately this Inselberg will also get eroded away. So this is the basic difference between the two. Now there are certain drawbacks of this concept also. It is not fully devoid of various errors. One of the drawback is that he had given too much importance on the endogenetic forces. And the order with which he had said the various Entwicklungs, it may not be very easy to achieve in normal circumstances. And this erosion was also criticized by various authors, by various other people. It has been criticized. And this is in brief about the difference between the division cycle of erosion and Penck cycle of erosion. Most of this I have already told you. I have already told you while I was taking the lecture. So I have already told you these. So you can just go through the various differences.